Hello everybody, in this lesson I will revise the laws of exponents. I will do a couple of examples and that example. The first law that we're looking at is the law where the bases are the same and we multiply, then we add exponents. So if you look in the green cloud, x to the m times x to the n is equal to x to the m plus n. If I give you 2 to the 3 times 2 to the 5, the bases are the same, therefore we add exponents. So it's 2 to the 3 plus 5, which is 2 to the 8. In the next example, it's x times x to the 5 times x to the negative 3. Now, first of all, if there's no exponent, then there's an invisible one. So that will become x to the 1 plus 5 negative 3, which is x to the 3. On this example, now we find coefficients in front of x squared. So on the coefficients, we will multiply them. 2 times 5 is 10, but on the exponents, we add the exponents. So it's x to the 2 plus 4. So the final answer, 10x to the 6. On this next example, this middle 3 has no exponent, so then there's an invisible one. Again, bases are the same, we multiply, therefore we add exponents. So it becomes 3 to the n plus 1 plus 4 minus n. And then n minus n is nothing, 1 plus 4 is 5. So the final answer, 3 to the 5. On this example, now there's brackets and there's exponents. So what we will do is we will get rid of the brackets first by saying let's multiply the coefficients first. So we find negative times 4 times negative 3 will become a negative times a positive is a negative, and a negative times a negative is a positive. And then the numbers 1 times 4 times 3 is 12. And then on the exponents, when we multiply, we add exponents. Therefore, it's a to the negative 1 plus negative 2 plus negative 3, and then it's 12a to the negative 6, and then we don't write this with negative exponents, therefore it's 12 over a to the 6 with a positive exponent. The next law that we will discuss is the one where when you divide exponents, you subtract them. So we start with x to the 4 divide by x to the 3, and then we can say the bases are the same. So it's the x is the base, and then 4 minus 3. So it is x to the 1. There's no invisible one. You don't have to write that. Next example, x to the 3 over x to the 4. That one is x to the 3 minus 4, which is x to the negative 1. And then x to the negative n is the same as 1 over x to the positive n. And this is a very important law to remember. This one is the one that helps you to leave your answer with positive indices. Index is singular, indices is plural. Therefore, that one, x to the negative 1, is the same as 1 over x. When I give you x to the 2p, divide by x to the p, bases are the same, we divide, therefore we subtract exponents. So it becomes x to the 2p minus p, which is x to the p. On this one, so with the coefficients, the numbers in front of the variables, we will just deal with it like a normal sum, and we will say negative 8 divided by 4 is negative 2. And then what happens on the exponents is on a, it's a to the 5 minus 3. So this 3 will go up and become negative, and b to the 2 minus 4. So the 4 will go up and become negative. And then when we just complete the sum, it's negative 2a squared times b to the negative 2. and then your problem is the negative exponent, and we make it positive by taking it down, and then when we bring it down, the exponent sign will become positive. So the final answer, negative 2a squared over b squared. And then on this one, again, when we divide and bases are the same, we subtract exponents. So it's 5 to the n plus 3 minus, and can you see now I introduced a bracket there since there were two terms under the line, so that now you can multiply in this minus and it becomes 5 to the n plus 3 minus n minus 1, and then we add like terms. N minus n is nothing, and 3 minus 1 is 5 squared, which is 25. The next law we will be looking at is x to the 0 is equal to 1. So that means anything to the power of 0 is equal to 1. So if I give you x to the 3 divided by x to the 3, in grade 9, when you expand that, you can write it as x times x times x over x times x times x. And then you would say x goes in itself once, x goes in itself once, x goes in itself once, x goes in itself once. And then you've got on top 1 times 1 times 1, and at the bottom 1 times 1 times 1, which is a 1. So that gives you 1. But then if I do this exact same sum, x to the 3 divided by x to the 3, and I use the law, when you divide, you subtract exponents, you find it's x to the 3 minus 3, which is x to the 0. And then this is in fact the formal proof of why anything to the 0 is equal to 1. But you don't need to worry about that. You just need to know anything to the 0 is equal to 1. So if I give you 5 to the 0, the answer is 1. When I give you something inside a bracket, minus 3x to the negative 1, it doesn't matter. Raised to the power of 0, the answer is 1. Now on this one, let's look at what happens here. It's negative 2x to the 4 divided by negative 6x to the 4. So on the coefficients, the numbers in front, we can say a minus divided by a minus is a plus, and then 2 goes in itself once, 2 goes in there 3 times. That's why there's a 3 under the line. And if you look at the exponents, we divide, so we subtract exponents. X to the 4 minus 4 is 0. Anything to the 0 is 1. Therefore, final answer, 1 over 3. Now, the next law that I want to show you is if I give you x to the m bracket n, it is equal to x to the m times n. So my advice to you is just remember that in normal maths, a bracket means multiplication. And where this comes from, I can even show you, is if I give you x to the 3 bracket raised to the power of 4, this is the same as x to the 3 times x to the 3 times x to the 3 times x to the 3. And then that one, the rule says when you multiply, you add exponents, and that is why it's x to the 12. So the short way is you could just say x to the 3 times 4 is 12. Next example, x to the 2 raised to the 6, or rather x squared raised to the 6 will be x to the 12. There's a bracket, so therefore you multiply. 2 times 6 is 12. So on this one, there's a bracket, therefore we multiply the exponents and we find it's x to the minus times a minus is a plus 15. Then on this one, we weight with this negative. And now we're going to take this 2 and we're going to raise everything inside to that power. So the minus outside stays, negative 2 squared becomes positive 4, and then here on the exponent, negative 3 times 2 is negative 6. and then in your next step, a minus times a plus is -4, and then x to the -6, we take it down to make it positive. Therefore, it's the final answer, -4 over x to the 6. And then I just want to show you here in the green cloud, even if you've got a division sum, then you can raise every part of your division sum to the power of m. So that one is x to the m divide y to the m. So if we look at a real example, what I'm trying to say is you take the -2 and you're going to raise every single variable to the power of -2. So it becomes x to the, and now -1 times -2 is +2, and then for y to the power 2 times -2 is -4, and then under the line, the denominator on the x, it's -2 times -2 is +4, and then there's no exponent there on y, so there's an invisible 1. So it's 1 times -2 is -2. And now it's the old rule where when you divide, you subtract exponents. So this, in terms of x, this 4 will go up and become -4, and the 2 will go up and become +2. We add, we find x to the -2, y to the -2, and then your final answer with positive exponents or positive indices will be 1 over x squared, y squared. On this slide, there's something I want to explain that we call rational exponent laws. So the first thing is, if I give you x to the 1 over a, it's the same as x under a root, and then your denominator becomes the type of root. So therefore, if I give you 25 to the power of a half, it's the same as the square root of 25. So can you see it was the denominator that tells you what type of root this will be, and then the square root of 25 is 5. Then we take it one step further. So now I give you x to the b over a is equal to, and then what you say is you take it, you write a root, the x is under the root, and then the denominator, the a, becomes the type of root, and then the numerator, the 1 on top, becomes the exponent of the base. So if I give you a to the 3 over 2, this will be the square root of a to the 3. So the denominator becomes the type of root, the numerator goes and stands under the root sign together with the base. And then that one has no real solution. You just leave it like that. And then the last one is if I give you x to the -b over a. Now, where does the negative go? So on the a, the denominator becomes the type of root, and then the -b, so the negative goes with the numerator, and it goes and stands underneath the root sign. So therefore, if I give you 125 to the power of -1/3, then this thing is the cube root. Can you see? The 3, the denominator, tells you what type of root this is, and then the -1, the numerator, will go and stand with your base. So that thing is the cube root of 1 over 125, which is a fifth.
In the next video, I will deal with expressions with exponents where there is multiplication and division. Click on the video in the left-hand corner to take you straight to the next lesson.